Okay, welcome America, welcome India, and welcome Taylor Swift to the live recording in Studio 212 today. We're going to be doing one problem for you. I will attach the worksheet. The directions say, Santa hat is just not great for implementing this fire video. It's fine. Okay. Find the exact value of each given that sine of beta is -3/5, and we've got this angle between pi and 3 pi over 2. So they tell us that it's between pi and 3 pi over 2. So here's pi, right? Here's pi, and here's 3 pi over 2. So the third quadrant is where you're going to draw your triangle. So I drew the triangle. Then I took the information that they gave us. The sine of beta is -3/5. Sine is y over r, or opposite over hypotenuse, and y is going down, so it's negative. The radius is always positive. I put my information there. This is a 3, 4, 5 triangle, which makes this length, and we may or may not need it. Looks like we're going to need it cosine in the formula. 4, because 4 squared plus the quantity -3 squared equals 5 squared. Pythagorean theorem. That's how we got the 4. All right, and this is your angle right here. Okay, so if we're trying to find the sine of beta over 2, okay, now we have to be careful about which quadrant that's in, because this is where beta is. Where is beta over 2? Okay, well, if I take my quadrant where beta is and I divide everything by 2, and that's going to become 4, it's going to be between pi over 2 and 3 pi over 4. Where is that? Pi over 2 is right here. And 3 pi over 4 is here. So it's somewhere in the second quadrant. What does that tell us? That's why the plus minus is in front here. Which one are we going to use? Where is this angle located? What is the value? Sine is y, the y distance, right? So where is the y distance, positive or negative in this second quadrant? Because that's where the location of the angle is going to be. Because y is going up there, right? So that's going to be positive. So out of the plus minus, we're going to select the positive. Is everybody okay with how we selected the sign of the formula that we're using? Okay, so I'm not even going to put the plus because, well, okay, I'll put the plus. We don't usually put the plus. If it's a plus, we just don't write anything. So here's our formula. 1 minus cosine of beta over 2. So let's go ahead and plug in the values. 1 minus, now we're going to use our triangle. Our triangle cosine is x over, this is negative, right? I forgot about the negative there. X over the hypotenuse or the radius. So that's -4/5. I think I forgot the negative. No, I didn't. Because that becomes 1 minus -4/5 over 2, which ends up being 1 plus 4/5 over 2. Is everybody okay with that? Now here's where people a lot of students have trouble, is right here, okay? Okay, so I'm gonna rewrite this. Actually, I'm going to erase this triangle, make some space here. So I was already efficient at the beginning of my video, so I can be less efficient now. It's fine. Everything's fine. Done. All right, I'm going to rewrite this over here. 1 plus 4/5 over 2. I am going to go ahead and multiply the numerator and the denominator of this fraction by 5 over 5, special one, because I'm not changing the value of the expression if I do that, because I'm multiplying by 1. 5 over 5 is 1, so I'm not changing the value. That way, though, gets rid of this fraction, and this becomes 5 plus 4 over 10. Which is, I'm just going to go across because I'm running out of room here. It's kind of a no-no. 9/10. And if I really want to be careful, I really need to simplify this because technically there's a radical in our denominator here because this is the square root of 9 over the square root of 10, which is 3 over root 10, which needs to be rationalized. 3 over root 10. Now I need to multiply by a special one again, root 10 over root 10. I'm getting 3 root 10 over 10. Done. That's it. Positive.
That was one question.
One question. Yeah, you'll have one just like it on your test. It'll either be sine or cosine.